All right, calculus. Um, on Friday, I had just done a quick video to go over any questions that people had. And I also put the answers to number 8 from your homework up because they didn't have the answers at the back of the book. So I did them myself for you in a video so you can check your answers. I have done some lesson planning, and if all went perfectly, and nobody had any questions, and I didn't have to take a day to go review anything or go over anything, if we were able to just push on through, oh, I don't have when a test would be, but it would probably be mid to late next week. I'm hoping to have it done by late next week. I think that's a little bit realistic. I think I don't know. It might even be the beginning of the next week, not sure. This is really the last big chapter we're gonna do. After that, there's only really 2 more chapters, chapter 7 and chapter 8. Chapter 7, the first half deals with logarithms and how to deal with them. We already did that in Math 12 in the first semester. I don't want to repeat information. We've already done it. So we're actually going to skip the first part of chapter 7 where they just tell you what a logarithm is and how do I work with them and stuff. That's not to say that I won't review a little bit of it as we go with you if we need to, but we're not going to do an in-depth, like let's do section 7.1, let's do section 7.2. We're actually going to start partway through chapter 7, and then we do some of chapter 8, and again, we don't do all of chapter 8, we do a portion of it. I think chapter 8 even says it's an extension, like not everybody does it, but I find it's helpful when you get to university, if you're headed into sciences and have to take a calculus class. I do find it's helpful. So we don't have a ton of stuff left to do. Yay! So we should be able to get through it all. I say should. We'll take it as it comes, but we should be able to get through it, I think. All right. So currently we are at section 6.4. So far what we've done is we've looked at increasing functions, we've looked at critical numbers, we've looked at local maximums and minimums, we've looked at points of where is it concave up, points of inflection, where is it concave up, where is it concave down. And we really have dealt with functions where the equation is just a straightforward equation, like 3x cubed minus 2x squared plus 7x plus 9. But what happens if you have a fraction? Because we know those exist. So what happens if you have a fraction? This is where the idea of asymptotes comes in. Don't groan too much, it's okay. This is where the idea of asymptotes comes in. You've done asymptotes before, so it's not new, but how we're going to talk about it, the language that they use when they talk about them is a little bit different. So you have to kind of get used to the language that they use when we do this. So let's say you have a vertical asymptote at x is equal to 2. Let's say you have a vertical asymptote there, all right? And let's say that when you graph whatever function that went with this, let's say when you graph it, it did this, okay? Let's say that's what the graph ended up looking like. When they talk about asymptotes, they talk about it in terms of limits, all right? And so when we talk about a vertical asymptote, this is specifically vertical asymptotes. When we talk about horizontal asymptotes, again, the language will shift slightly, all right? But when we talk about this, if this was our scenario, remember back talking about limits, about left-handed limits and right-handed limits? Well, we're going to talk about that here. If I asked you, what is the limit as x approaches 2 from the left-hand side? Well, if I have an asymptote at 2, and as this is the left-hand side, this is the right-hand side, right? Left side, right side, okay? As I approach 2, as the graph gets close to 2, the graph just continues heading upward. So the limit is actually infinity. It keeps going up to infinity. The closer it gets to 2, the higher it goes on the left-hand side. On the right-hand side, the limit as x approaches 2 from the right-hand side, well, again, here's the right-hand side. As I approach the asymptote, as I get close to the asymptote, it goes up. So it also approaches infinity. So if I asked you what is my limit as x approaches 2, you would just tell me infinity. There's no actual answer because it just goes up forever. Now what if I shift this just ever so slightly? What if on the right hand side, what if it did this? Okay. So again, the left hand side didn't change. So my limit as x approaches 2 from the left hand side is still infinity. But my limit as x approaches 2 from the right hand side, again, right hand side, I'm going to approach, I'm going to get close to, I'm going to come toward the asymptote. As I come toward the asymptote, the graph, the line heads down. So that means it is negative infinity. So if I ask you overall, what is the limit as x approaches 2? Well, it does not exist because it is approaching 2 different things. On one side, it's infinity. On the other side, it's negative infinity. Now, there are also horizontal asymptotes. We're not going to talk about those today. So even though some of the graphs we're going to do have horizontal asymptotes, we're not going to talk about them today. So if you're like, why is she drawing it that way? But she's not talking about the asymptotes going horizontally, that's because that's in tomorrow's lesson, all right? So, if you have an asymptote and I'm asking you about a limit as a graph approaches the asymptote, then your answer is always either going to be infinity or negative infinity because it's always either headed up or headed down because it's an asymptote. Like that's what defines an asymptote, right? So, all right. So we are going to do 3 examples, just 3, all right? So in number 1, it says evaluate the limit as x approaches 0 from the right-hand side. The limit as x approaches 0 from the right-hand side and the limit as x approaches 0 from the left-hand side for the graph 1 over x. So I want to know the limit for that. I know that I can't put 0 on the bottom of a fraction because I'd have 1 over 0, which would give me nothing. We don't even have to graph this, really. You could if you wanted to. If you prefer graphing it, then you could graph it. But I don't even need to do that, really. I'm going to do a little, it's not really a table of values, but I'm going to do something where I'm going to take a couple of values. So as x approaches 0 from the right-hand side, so if I think about a graph, here's 0. The right-hand side is this side, so here's 1. 1's not really very close. I mean, it's close in terms of, you know, between 1 and 100, 1's a lot closer, but it's not really close. We want close. So we're going to say like maybe 0.1. What if I do 0.1? Well, 1 divided by 0.1 is 10. What if I went even closer? What if I went 0.01? That's even closer. That's even closer to 0. If I did that, 1 divided by 0.01, I get 100. Notice it's going up exponentially, which means that it's approaching positive infinity, because it's positive 10, positive 100. If I did 0.001, it would be positive 1,000, right? So what about from the left-hand side? From the left-hand side, again, if I did the same idea, negative 0.1, 1 divided by negative 0.1 would be negative 10. If I did negative 0.01, that would be negative 100. And so it's going down, so that would be negative infinity. So if I wanted to graph, not the whole graph, but just what it's doing close to the vertical asymptote, on the right-hand side, it's headed up. On the left-hand side, it's going down. Again, I'm not finishing off that graph. I don't know what it does beyond that. I'm just talking about the portion of the graph closest to the asymptote. That's what it's doing. All right. That's example 1. That's all they wanted you to do. And again, you don't have to graph anything. You don't even have to do a table of values. Just throw a couple of values close to 0 on the right-hand side, close to 0 on the left-hand side into your calculator and see what you get. Example 2. All right, find the limit as x approaches 5 for 4 minus 3 over x minus 5 squared. Well, that's disgusting, but I know I can't just put 5 in here, because 5 take away 5 would be 0, squared would be 0, and I'd have 3 over 0, which I can't have. So, again, what I would do is I would just I would just do a quick table of values, and they want to know overall 5. So you have to know, what is it doing? So if here's 5, you have to know what is it doing on the left-hand side. So let's say 4.9, and you have to know what it's doing on the other side, say 5.1. Remember I said it's pretty much always going to be infinity or negative infinity. You just need to know which one. So I would just take 4.9 and put it into here. 4.9 minus 5 squared, and I would do all the math that goes with it. Like I would square it, do 3 divided by that, then do 4 minus that. Turns out it's negative 296. And that seems, I'm cheating, so that seems like 4.9 minus 5 squared, 3 divided by that, and yep, 4 minus that, yeah, because it was 300, so 4 minus, it's negative 296. So at 4.9, it's negative 200, it's headed down there, so it's negative infinity. So the limit on the left-hand side is negative infinity, but what about the right-hand side? So I'll do 5.1. If I do 5.1, I also get negative 296. So because it's the same on the left-hand side and the right-hand side, I can say that overall it's negative infinity. So this isn't rocket science. Pick something right before, something right after, stick it in, see whether it's infinity or negative infinity. Example 3, there are 2 parts. There is part A and part B. I am going to do both of them. They're not super long. Okay, so find the vertical asymptotes for each function and sketch its graph near the asymptotes. So again, I'm not looking for a big extended graph, just what's happening close to the asymptotes. So A is x plus 1 over x squared plus 3x plus 2. Okay, first thing I would do is I would factor the bottom to be x plus 2 and x plus 1, because 2 plus 1 makes 3, 2 times 1 makes, right? But see, notice I've got an x plus 1 on the top and an x plus 1 on the bottom. So this is really 1 over x plus 2, which is a whole lot easier. So, again, my only asymptote is at negative 2. My only asymptote is at negative 2. So I would do a quick table of values. So on the left-hand side, maybe negative 2.1. On the right-hand side, maybe negative 1.9. So at negative 2.1, negative 2.1 plus 2 is negative 0.1. 1 divided by negative 0.1 is negative 10. You can use your calculator. So at 2.1, it's negative 10, which means it's headed down. And at negative 1.9, negative 1.9 plus 2 is 0.1. 1 divided by 0.1 is positive 10. So it's headed up. Now it just said to graph near it. So that's all really you have to do. They give the full graph in the textbook, but they didn't say that. They just said graph near the asymptotes. They just want you to know, they just want to know, do you know this? We'll fill in the rest of it later, like when we start talking about things like horizontal asymptotes, etc. We'll talk about that after. But today, we're just focusing on vertical asymptotes. All right. B. X over x squared plus 2x minus 15. So again, because there is a trinomial on the bottom, I'm going to factor that. I'm going to try x and x. And if I do positive 5 minus 3, that'll give me 2. Okay. And so x could be negative 5 or positive 3. It doesn't cancel anything on the top. So there's actually 2 vertical asymptotes here. There's actually 2 of them. There's one at negative 5. And there's one at 3. So I'm going to pick something here like negative 5.1, here like negative 4.9. I'm going to pick like 2.9 here and 3.1 here. So x and y. So for my table of values, negative 5.1, negative 4.9, positive 2.9, and positive 3.1. So something just on either side of each of the asymptotes. So if I do negative 5.1, turns out that I get a negative value. Okay, and I'm cheating, by the way. Turns out I get a negative value, but I would just put it in there. Turns out I get a negative value. If I do negative 4.9, turns out I get a positive value. If I do 2.9, put it back in here or here, won't matter. If I do 2.9, turns out I get a negative value. And if I do positive 3.1, turns out I get a positive value. Sorry. Again, I'm not asking you to draw the whole thing, although this actually would just do this, and this would actually just do that, and that would do that. It's not, I mean, it's not really hard to do, but they only asked you to graph near the asymptote. When I get you to do it on a test, because you will have all the information, you'll be graphing the whole thing. But for right now, that's what we're doing. So that is section 6.4 on vertical asymptotes. I will have a few for you to do, okay? I will have a few for you to do. And that's it. Talk to you later. Yes, hi, Katie.